Okay, today we are going to do a Too Tall Toby practice model. This one is available to the public. This is the bearing bracket is a level 4 or tier 4 drawing. So let's give you a preview of what we're going to be working on. And there it is. So millimeters, aluminum alloy, bearing bracket. I'm going to start with the long portion across the bottom. Then I'll add on this section here with the hole, add a round, mirror that over the center line, add the slot. And then the rounds on the back here are actually a little challenging that those are not following the tangent curve. So that does add a little interest to this particular part. So we're going to go ahead and get started with that. And I've got a part with the name 240102, but I've used a template that I've created. So this template has the 4 Too Tall Toby materials added into it. I know that this one's going to be alloy. The mass properties are calculated and displayed on as a flat to screen annotation. So that's going to give me my mass when I'm done. So in the meantime, I will go like that. We will put the mass properties at the bottom and we will recover them when we are done. All right, so going back to the Too Tall Toby, I'm about ready to hit try again. I have done this once. So we're going to try this again, try to get a little better time, and talk through some Creo things as we're going through. So here we go. We will hit reveal and get started. So we'll start with an extrude on the right plane, and we're going to just do this with lines here. We're going to go. And I'll use symmetry. There's lots of ways to do this. We're going to, let's see here. This whole dimension here, this one's going to be 54. This is going to be 16. Some of the dimensions aren't what we look for, so we'll have to add those in. All right, so let's throw a whole bunch of symmetry on here. There we go, and let's add one down here. And let's add one here. Okay, and then a few more dimensions to go. So we need this angle. That wasn't the right angle. Let's try that again. 60 degrees, and we need the height of the V slot. There we go. All right, and we will extrude that for a depth of 118. And let's add a side. This has an overall width of 55. That's actually the diameter of the arc on the top. This is going to be a height of 42 minus 16. Add a circle. And I'm going to add a datum point. That'll give me an axis that I can use. There won't normally be an axis there. Let's turn that into construction. And let's get rid of this piece. And we're good to go. So we're going to flip that around and extrude that 14. Okay. So with that axis there, I can drop a hole on it. This is going to be a drilled counterbore hole. Diameter is 30. We'll hold down control, grab that face. There we go. Diameter is 38 for the counterbore with a depth of 4. And we're going to send this all the way through. Where to next? Okay, let's add a round on before we This will be 12 before we mirror that. Beautiful. Let's get that slot added in here. Easiest way to add the slot is from the palette tool as a racetrack. Place that down. Some dimensions. 1699. Make that stick to the edge. And we're going to drag it and dimension where that goes. All right, and we'll flip that and go through all. All right, last thing to do is add some rounds. So the rounds are a little interesting. We're going to do these as 6. We're going to get both of those together. Then we're going to add a new set and the details on this one, it's going to be a partial loop. It's not going to be tangent. And then for our, we're going to add that one in there too. And that's how we get that not tangent. And we'll drag this down. And it says Control G, Control G. So we're going to regenerate, Control R, we got 309. And there we go. So there is your Creo bearing block part done in Creo. I recommend having these materials added ahead of time. It really does save some time. A couple of things there. The slot from the palette tool, adding the point to get an axis for an axial hole. Just a couple of little nuances about modeling in Creo.